For today's topic, we're discussing translations. This is a rigid type of transformation, and our essential question is, what type of movement is a translation, and how do we record it in formal notation? Please take a minute, pausing the video if you need to copy down the topic and essential question into your header, along with today's date, set up your question column, and the note column, and resume the video when you're ready to begin. We'll start today, as we often do, discussing vocabulary. So as a reminder, translation is a transformation that slides a figure a fixed distance in a specified direction without turning it. The pre-image is the original figure or object before a transformation, and the image is the result after a transformation. We'll see in today's video that the new coordinates for an image are called prime. So be looking for that notation and the use of that when we are describing the new coordinates of any new image. Let's go ahead and look at our first example. In our first example, we're looking here at triangle P. It has the coordinates A, B, and C to make this right triangle. And you can see I've recorded the coordinates for A, B, and C of this triangle to the right here. A is at -7, 8. B is at -2 on the x-axis and 1 on the y-axis, while C is at -7 for the x-axis and also at 1 for the y-axis. And we're trying to figure out what are the new coordinates A prime, B prime, and C prime of the image after a translation. And here they're using notation to describe the translation that they want us to use. They're using the notation here, which is referred to as tab, or at least that's what I call it. The capital T tells me they want a translation. The A describes the horizontal movement along the x-axis, and B describes the vertical movement, the up and down movement, using the pre-image's y-coordinate. So, according to this, can you tell how far horizontally they want us to translate triangle P? Well, if you said 9, I would agree with you, because that is in the A position. So it's going to translate 9 units to the right, because it's towards the positive 9s, and 0 units vertical. So it's not going to move up and down, it's only going to move to the right 9 spaces. Let's go ahead and count that out. So again, since the first number here, the A position, says 9, that's a horizontal movement, so point A here of our triangle is going to move positive 9 spaces, so 9 spaces in the positive direction. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And that will be the point where my new A prime will be. And then I could also count that out for C to find C prime, as well as for B. Why don't you pause the video and take a moment, see if you can find those new points. How'd you do? Here is our resulting image of the pre-image triangle P, and we should have found A prime to be at 2, 8, B prime to be at 7, 1, 7 on the x-axis, 1 on the y-axis, 7, 1, and C prime to be at 2, 1, because that would be each point translating or sliding 9 units to the right. And remember, 0 in the B position is our vertical movement, and it didn't have us move it up and down at all, since that is 0. So these would be A prime, B prime, and C prime are the points of our image of triangle P after translation 9 units to the right. I want to show you one more way to note this type of translation. So I've included it here, and this is one way of notating it, again the tab notation, but it's also helpful to go right from the tab notation to what they call mapping, or the mapping notation. So we just take, you'll sometimes see it this way where it's the original xy, meaning the original coordinates for the pre-image, which is always listed first, and then an arrow showing that it's undergone some sort of transformation. And in this case, we have x plus 9, saying take the original x coordinate of the pre-image and add 9, just like that 9 stands for there, and then take the y coordinate and add 0, again the B position here in our tab notation. And if sometimes you'll be asked to do this without having a graph to count it on, so you might see this notation and just be given the original points. And so with that you could say, well, my original A x coordinate is -7. If I add 9 to -7, I get 2. Then to get the y coordinate, it says take the original y, add 0, well 8 plus 0 is 8. And we would see that that would work with each of these. -2 plus 9 gives us 7, our new x coordinate. 1 plus 0 gives us 1, our new y coordinate. And then for C, -7 plus 9 is 2, and 1 plus 0 is 1. So this is one way of notating it in the tab notation for a translation, or we can use mapping notation. So let's take a look at one more example to see how that works. For our second example, we will again be looking at a triangle under a translation, here using that tab notation. I've recorded in the box on the right the ordered pairs for each point of our pre-image for triangle R with points L, M, N, and we're trying to find the new points for the image of this triangle under this translation. What I'm going to suggest for this example is that we use the tab notation to use the mapping notation and then try and find the new coordinates. So let's go ahead and take a look at what that would look like. So since in the A position it says -7, this first number always tells us the horizontal movement that they want for this translation, which is our x coordinate. So in our mapping notation we're saying take the original coordinate and from the x value subtract 7. So we're going to go towards the negatives 7 spaces. In the B position it says -3. This, remember, is our up and down, our y-axis movement, and so it wants us to go down 3 since that's a negative number. So our y coordinate, the original y coordinate, from that number we will subtract 3, and that will tell us the points for our new image after the translation that they are requesting here with -7, -3. From here, you could either just move it by counting, so we could pick the points and count it back 7 to go to the left 7, and then down 3, or you could use the points and subtract 7 from 3 to get your new x coordinate, and subtract 3 from 7 to get your new y coordinate, figure out your new coordinates, and then plot them. So I'm going to give you a moment to pause it here and see if you can find the image of triangle R. How'd you do? So after that translation, 7 units to the left and 3 units down, we're subtracting 7 from our x coordinate to move it left, and subtracting 3 from each y coordinate to move it down 3, our new image of this triangle should be L prime is at -4, 4. M prime would be at -1, -2, and n prime would be at -6 on the x-axis, -2. And we can check that by making sure that we can count that it goes to the left 7 and 1 to go back 7 for the horizontal movement towards the negatives. 1, 2, 3, 4, 5, 6, 7 for this first movement, and then down 3, 1, 2, 3. And we could check that with each point that it would, but I'm not going to for sake of time, but you can check each of them. That's going to conclude our video for today. Please make sure your notes are complete with the diagrams of each graph, and be sure to include a summary that answers the essential question from the header in your notes, which was, what type of movement is a translation and how do we record it in formal notation?